Okay, so welcome to our channel Hariharan Express channel. Today I will discuss new topic, that is decoders. Okay, so this new topic I will discuss today, that is decoder. Decoder is actually a circuit. So I will define that is what is the how decoders is designed. First of all, what is decoders? A decoder can be described as a combinational circuit that converts binary information from the n number of inputs, or n coded inputs we can tell as a n coded inputs, to a maximum of 2 to the power n different outputs. Okay, if you will consider that is n inputs, you see very simple way I will tell you how decoder is designed or defined. That is, it is a combinational circuits that converts binary information from, that is n inputs. N inputs means suppose n inputs we will consider. Okay, then how many outputs we can get it? The output can get like a 2 to the power n output. If we will provide n input to the circuit, then we can get that is a 2 to the power n output. Okay, so this is the number of inputs and output whenever we will use these decoders. Okay, and the decoder whenever defined, that is the name also we define accordingly. Like very simple way we can define, that is n to m decoder. Okay, n to m decoder means what is n, what is m? N is, I told, n is input, means n number of input we will give. Then decoder provide m number of output. Okay, m number of output, and that m output is defined through 2 to the power n. Okay, that means m output defined 2 to the power n, where n is input. Then the decoder can be named, can be called as n to m decoder. Other short form also we can define, like suppose for example we can take for name for the decoder. What is the decoder type? Okay, not a decoder type means we can tell what is the decoder, and what kind of a decoder we can consider. Like suppose n is equal to 2, then m is equal to how much? 2 to the power 2, that is 4. That means if we will consider 2 input, then we can find that is 4 output. Okay, 2 input, 4 output we can get it. Similarly, if n is equal to 3, then m is equal to 2 to the power 3, that is 8 output. Okay, input we will provide 3 input, we will get 8 output. Based on that we can tell what kind of a decoder. Okay, what kind of a decoder we can construct, we can design based on the number of inputs and number of outputs. Here is similarly n is equal to 4, so m is equal to how much? 2 to the power 4, that is 16. Okay, so different output can be considered or can be designed based on number of inputs. This is the basic concept. So based on that we can tell what kind of a decoder name. Like we can tell here basic concept we defined, like n to m decoder. If n to m decoder, m is the input, m is the output. Then we can also tell like this, for example the 2 to 4 decoder we can also call as like this, like the 2 to 4 decoder means 2 input is there and 4 output is there. So 2 to 4 decoder. Similarly, if we consider 3 input, like 3 to 8 decoder. Okay, 3 to 8 decoder. Similarly, 4 to 16 4 to 16 decoder. Okay, so different name we can call whenever we will consider different inputs. Based on that, different output we can get. Okay, so different output is absolutely depend on what inputs. So based on that, we can design the decoder. So different decoder whenever we will design, we have to consider how many number of inputs we will consider. Based on that, output we can define. Okay, so this is the basic concept whenever you design the decoder. But whenever we will consider decoders, then we can see that how it will be designed. Okay, I have already told decoder is a combinational circuit. Okay, I told that once again, decoder is a combinational circuit that converts binary information from n input, n coded input to m number of output. This is the basic operation whenever we use decoders. But now I will design how decoder is designed through that is a AND gate. We will go through that is a design of a decoder through AND gate. Now I will show you how decoder is designed through AND gate. Okay. Now I will show you how it is designed. Very simple way. That is whenever I go through that is AND gate or decoder, I already told that they depend on that is inputs. Okay, depend on inputs. Now we see how it will be designed. Let two inputs we will consider. Let us consider that is A0 and A1. Okay, A0 and A1. Since two input we will consider here, you see very simple way. Two input we will consider, then how many output we can get it? That is a 4 output, because we will consider only two input. So obviously 4 output we can get it. So how to get 4 output? Those 4 output, let us consider 4 output we can consider through D. Let us consider first of all, we will see let input, we see let input are A0 and A1. Okay, let input is inputs are considered as A0 and A1. Similarly, output we can consider output. You see output also consider as D0, D1. Okay, D1, D2 and D3. Okay, because we know that if two input to consider, then automatically it will create how many output? That is a 4 output. The 4 output we will consider as D0, D1, D2, D3. Okay, how these 4 decoder will consider? How do it is designed, which is based on two inputs, and we will design this decoder based on using AND gate. Okay, now you see very simple way. 4 AND gate we will consider very simple way. This is the AND gate. 4 AND gate we will consider like this. Okay, and each AND gate provide that is a 4 output. Okay, these 4 that is AND gate provide 4 output. Now you see how 4 output it will provide. And whenever provide 4 output, we will consider as that output in this manner, like here is D0, here is D1, here is D2, here is D3. Okay, starting from D0, next D1, D2, D3. That means 4 output we can find out based on 2 input. Now we will design. How we will design? You see, whenever you go through these 4 input output, it is depend on this 2 input, and result of that output can be considered as, you see, I will show you how the result we can get it. Like suppose A0, okay, A0, 0 is suppose A0 and A1 is 0, A0 is 0 and A1 is 0, then what happens? Result will be 0, 0. Okay, result will be 0, 0. Similarly, if A0 is 0, A1 is 1, the result will be A0, 1. That is considered for output through D1. Similarly, if A0 is 1, A1 is 0, then output will be 0 or considered as a D2. Okay, so in this way all output can get through D0 to D3, which is defined through A1 to A0 or A0 A1, two inputs. Now we see, if we go through 0 0 output, how will we get 0 0 output? That is important. How do we get it? That means see, one part is 0, another part also 0. Whenever we will provide some input through A0 and A1, then what happens? We will provide the input normally 1. Okay, if we go through 0, we can also provide A0 is 0 and A1 is 1. But both A0 or both 0 or 1, whenever we provide, how it will convert 0 and 1? Okay, if suppose we will provide 0, how it will convert 1? If you provide 1, how it will convert 0? Okay, that is the important part to find out 0 0 or 0 1. Okay, in this case what happens? One inverter will consider like you see very simple way. I will design or I will use this inverter in this manner. Okay, very simple way. I will just draw this inverter. One part is connected A1 with inverter, another one input also connected to inverter, this one, and another also input connected to inverter. Now we will see how it will link to find out different output. Okay, now we see, since it is 0 0, very carefully we will see, since it is 0 0, then what happens? Whenever A1 0 and A0 0, then obviously that data it passed to the particular this AND gate, then we can get that is 0 0, because if we go through, suppose A0 provide 1, A1 provide 1, automatically inverter that is provided 0. If it is 1, it will be 0. If it is 1, it is 0. So 0 0 pass to the that is particular AND gate to provide 0 0, which is received by the D0 or output will be D0. Okay. Next, you see very simple way. That is here is we can also define very simple way. That is here is 0. We can tell as this is 0 A0 and this is as you like. We can define, no problem. Either here is A0 or here is A1. Suppose here is A0, here is A1. As you like, 0 0. Okay. First part is this one A0, this is A1, or reverse case also we can consider. Based on that, we have to link in which part to the individual output from this input. Now we see here is A0, A0 is 1. If A0 is 1, then what happens? We will consider this is A0. Now you see very simple way, this is 1. Now we will consider this is 1. Okay, A0 is 1. Next, A1 is 0. A1 is 0 is here. So now here one connection we will consider here. So this is 0. A1 is 0. A0 is 1. Okay. In this way also we can find that is 0 1, which is determined by output D1. Okay. Next, here you see that is A0 is 0. Now A0 is 0. You see very simple way, A0 is 0. Now we will see the A0 is 0. Okay. So A0 is 0 and A1 is 1. Now if A1 is 1, then another line we draw from A1, that is 1. Okay, that is 1. In this way we also find A1. So this is A1, A0 and A1. Next, similarly, D3, that is 1 1. Here D before inverter all value will be 1. Now you see that is a 1. You see very simple way I will connect, that is 1. Okay, like this. So here is 1, very simple way. Here is 1. Okay, that is another is 1. So 1 1. Very simple way, it is a 1 1. So whenever we can get this data 1 1, then we will collect data from A0 to A1 directly. Here is A01, A1 is 1. So that data we can get in this manner. Okay. So this is the basic combinational circuit where 2 inputs we will consider in this way and 4 output we can consider in this way. Okay, very simple way. So you have to design accordingly. Either here whenever the data, different data or information we will consider A0 here or A1 or this is A0 it is 1. Based on that we have to connect which inputs connect to direct this AND gate according yourself. You will design accordingly, doesn't matter. Okay, this is the basic concept. Now we will see whenever we will consider that is 2 inputs, how truth table will design. That is I will show you how truth table is designed based on this logic circuits. Okay, now we see we will consider that is 2 is suppose truth table. Now we will consider truth table. How truth table will design based on this logic circuit. Okay, now we see very simple way. Now we will see here is a suppose A0. Okay, here is a A1. So output, how many output we can get it? Like a D0, D1, D2, D3. Okay, now separately we just define. Very simple way, separately we define here. Okay, so I draw this by which we can find out what is the data, what data we will provide through input and what data we can get. Okay, very simple. Okay, now you see here D0 depend on A0 A1. A0 is 0 and A1 is 0, both are 0, so that is no problem. We will consider this 2 0 consider as a 0 0. Here is 0, here is 0. So obviously D output will be activated. So this particular output we can activate, that is 1. Okay, D0 that is 1. In this case what happens? Other part will be 0. All part will be 0. Only D0 will be activated. Okay, we will consider in this way. Similarly, other way also we can consider like 0 1 means here we can see 0 1. 0 1 means here A0, but other way also we can consider like here also different ways also we can consider, but based on that we can consider here. Or if we go through this one, that is also designed accordingly. Okay, now we see if we go through 0 0, very simple way. 0 means A0. Okay, A0 or other way you can write here is A0, here is A1. Okay, A0 A1. In that case what happens? Here A1 A0. Okay, in this case what happens? 0 0, here is 0 1. A0 is 1. So A1 0, A0 1. Then what happens? Which output we can get it? D1 we can get it. Okay, or D1 it will be activated. So D1 will be 1, other part will be 0. Okay, very simple. D1 will be 1, other part will be 0. Next, similarly, here is we can take that is here is 1. A1 is 1, A0 will be 0. Okay, A0 will be 0, A1 will be 1. Then what happens? 1 0. 1 0 is what? D2. So D2 will be activated, other part will be 0. Okay, other part will be 0. Similarly, other that is A0 is 1, A0 is 1, A1 is 1. Okay, so in this case what happens? Similarly, who will be activated? D3 will be activated. This will be activated, other part will be 0. Okay, in this way we can also, that is, design this truth table. Okay, that is a truth table also design in this way. So first of all we will create this decoder circuit. You can write here decoder, okay, logic circuit, decoder logic circuit design in this way. Whenever we will apply the truth table based on this decoder logic circuit, okay, we can define this truth table, or we will analyze this truth table in this way. So it is very simple way we can define. This is actually this is A1, this is A1, this is A0. Okay, now this is the so here what kind of a decoder will we consider, we will design? That is another question. We consider, although we consider this decoder logic circuit, which decoder will we consider here? That is a 2 to 4 decoder. This decoder name is 2 to 4 decoder. We can call this decoder name is 2 to 4 decoder. This is the basic concept of a decoder. Whenever we consider this decoder, we have to design in this way. So very simple way. First of all, we will see how many number of inputs we will consider for a decoder, how it will design. Okay, either it will design through that is AND gate or NAND gate also we can also define, or we can consider AND gate or NAND gate. Okay, next time that is lectures I will also show that is NAND gate, how NAND logic gate use for a decoder. Next class I will that is define, I will explain how NAND gate use for decoder. Another class also I will take, like here define 2 to 4 decoder. Next class I will define how define through 3 to 8 decoder. Another similarly same concept I will apply to design 3 to 8 decoder. Very simple way. That is A1, A0, similarly A0, A1 and A2. 3 inputs we will consider. Similarly, the decoder also define accordingly. That is output we can get like D0, D1, D2, D3, D4, D5, D6, D7. Okay, 8 number of output we can get accordingly. Okay, so this is the basic or fundamental concept of decoder, how to design the decoder, how to get the output through decoder whenever we will provide number of inputs. The basic and fundamental concept I explained. I hope all of you understand. So all of you I hope understand this topic. It is very easy topic. So thank you very much. Please share my please share these videos and subscribe my channel. If you like it, so like this channel, and if you comment something regarding on this topic, you can comment me. Okay, thank you very much. Thank you, and thank you watching this videos. Okay, thanks. Thank you very much. Thanks.